The pale blue dot. This is the most iconic picture of all times for humanity. Maybe it's not the most famous one or well known, but look at that. This is us. Actually, it's our planet Earth, where we are, in 1990. It was the first image of our Earth from so far beyond, and the goal of this picture was to understand if we can detect the life on our planet, if we did know it's there. When I saw it recently in the social media, it sparked a lot of memories about this image, and I decided to make this little short video. Let's dive into the story. And the story will start from 1986, the Challenger catastrophe. Everybody remember that it happened in January of 1986 when a space shuttle was launched to its mission and something went wrong and it didn't make it out of our planet atmosphere. Apparently, from all the disaster that's caused for the people and researchers on this shuttle, there was the failure of their expedition of Galileo that was supposed to be launched that time as well. Galileo Mission was to launch towards the Jupiter and was finally launched in 1989 since this catastrophe. And one of the project scientists, you'll be surprised, it was the famous astronomer Carl Sagan. Famous because he's the one who did series of documentaries and he famous to the general public. He had very extraordinary idea. He decided to use the Earth flyby as an opportunity to point Galileo's instruments to our planet and to see if they can detect signals of intelligent life solely from the data sent back. It was a late 80s. That time NASA spacecraft flown by upwards of 60 planets and moons, and nobody spotted any life there yet. Later, the Carl Sagan was saying, if we find signs of life on Earth, it means negative results we find elsewhere really are significant. NASA liked this plan, and Galileo approached Earth first time round from its nighttime side, flying past in December 1990, it was 8 December, about 960 kilometers above the Caribbean Sea, and they used the system of 3 spectrometers of ultraviolet, visible, infrared, and radio regions of the spectrum. And they treated the data as it would be received from the alien planet. The planet we don't know had life or not. And we will not know if there is a life existing there or not. And we're trying to understand, in such close range, how difficult it will be to spot telltale signs of life. One of the members of the crew, he was saying, they struggled hard to find any proof at all to start with. The technology was at that time much worse than now, you can imagine. It was 1980, Galileo photographic resolution was about 1 kilometer per pixel at the best. It means we can see only artificial geometrical structures which have some kind of symmetry and have a big scale, so we can see that like cities, agriculture fields and so on. They did the highest resolution images of Australia and Antarctica, and both are sparsely inhabited. As we know, in Australia coastline, agriculture offered a hint of something kind of like life, but wasn't judged sufficiently distinctive to be indicative of intelligent life. It was a very poor start for these live detectives that time. But there was a good news that there was a water on our planet and all type of its form. And we knew that the liquid water was very necessary, but not sufficient to have a life. Galileo also spotted the Earth's atmosphere, and there was a methane. The methane, it's not necessarily the sign of life, but the methane broken down by sunlight. So any leftover from the formation of the solar system should have long ago disappeared. It means that something's on the surface of this planet producing the methane. And we know that the methane produced on our planet, for example, from bacterial respiration, rice farming, and of course the cows and other animals. But methane is also generated by volcanic activity, so it's not very true representative of the life on the planet. Another good detector is the high level of oxygen in atmosphere. It's very reactive gas, and it's form more stable compounds over time. So it means something on the surface is pumping it out. Earth's landmass provide another important clue. Much of the planet's surface was covered with a green pigment that strongly absorbed light in the red part of the spectrum. At the time, team reported that this pigment corresponded to no plausible mineral, and it's chlorophyll. And it's making this cliff-like dip in the spectrum of light Earth reflects. Astrobiologists now call this the red age, and they think its presence is uniquely indicative of the light-harvesting molecules involved in the photosynthesis. This red age, combining with other points, might strongly suggest that there's a life on the Earth. But however, scientists of the team were not very satisfied. They say that this evidence that Galileo discovered could be discovered by similar flyby spacecraft as long ago as about 2 billion years ago, before any intelligent life was there. The only last clue that was detected about the intelligence on the life, it was the plasma wave spectrometer picked up narrowband radio transmissions coming from the surface. We don't see natural radio signals looking like that, said one of the scientists, and they were picking up the taxi communication from South America. And the team wrote in a Nature paper, cover story in 1993, that of all Galileo science measurements, these signals provide the only indication of intelligence, technological life on Earth. And that's how they were searching for life on Earth from the Galileo spacecraft. At the time, the paper wasn't very exciting for the public. Nobody was interested much in that. However, it was a new approach, a new reverse research understanding. Let's study ourselves to understand the world around us, as I see it. Scientists from NASA said that Carl Sagan was ahead of his time, probably by a decade or more that time. And the discovery of an exoplanet orbiting Sun like stars had inspired a new generation of astronomers looking for signs of life in the atmospheres and on the surface of far-off planets. The question there is whether starlight passing through the atmospheres of these distant worlds betrays signature ages or other features that can't easily be explained away without invoking life, just as Galileo flyby did with Sagan's pale blue dot. So this photograph of Earth was taken on February 14, 1990, by the Voyager 1 at the distance of 3.7 billion miles or 6 billion kilometers away from the Sun. And the image inspired the title of the Carl Sagan's book, Pale Blue Dot, A Vision of the Human Future in Space. And he wrote there, look again at that dot. That's here, that's home, that's us. The Voyager 1 was also make a photograph of other objects in the Sun, in our solar system. They were trying to make a family portrait of our solar system. And you can see on this image that we have the images of other planets in the Sun. This view was simulated using NASA Eye on the Solar System app. That's what the Voyager 1 see. And they call it family portrait of the solar system, including the pale blue dot image. He took images of Neptune, Saturn, Uranus, Jupiter, and Venus. Mars wasn't very friendly, he was obscured. Sunlight bouncing around the camera, and Mercury was too close to the Sun. Pluto was too tiny, too far away, and couldn't be detected. On the NASA website, they described that the image gave human an inspiring and unprecedented view of the home. And not just that our Earth looks like a speck of light, while other planets looks exactly like that. although now we know so much about those giant planets, like a Jupiter for example, and how many stories and secrets they bear. This family portrait remains the first and only time a spacecraft had attempted to photograph our home solar system. And only 3 spacecraft so far have been capable of making such an observation from such a big distance. It's the Voyager 1, Voyager 2 and the New Horizon. And Voyager 1 was launched in September 5th, 1977. He was traveling past Jupiter on March 1979 and Saturn in November of 1980. And you can see some of those first images of the Voyager in my previous talks about those planets. And after snapping these pale blue dot images, the family photos, in February 14, 1990, how iconical, on the Valentine's Days he did this. He powered off his camera forever because they wanted to save the energy of this spacecraft for the long journey ahead. In August 2012, Voyager entered interstellar space, so outside of our solar system, or the edges of our solar system, and now the most distant human-made object ever, or at least the one we know so far. It's a very exciting and interesting story about exploration of other planets, exoplanets, through looking on our own one. It'll be interesting to know that Carl Sagan, he's not just an amazing man who documentaries we all watched when we were young and get inspired by. He played a leading role in the United States space program. He was a planetary scientist and advisor for NASA beginning from 1950s. He briefed the famous Apollo astronauts before the flights to the moon. He helped design and manage the Mariner 2 mission to Venus, Mariner 9, Viking 1, Viking 2 trips to Mars, Voyager 1, Voyager 2 missions to outer solar system, and Galileo Mission to Jupiter, the one that was researching about our planet. Can we find a life there or not? Now I hope you will remember this image and always trying to picture it when you understand that your problem seems too very big and important. After all, we're just a little tiny pieces of organic matter trying to make our life right on this little dot of dust rotating in a vast space. And remember also, if you're trying to understand somebody or something around you, first look at yourself, and maybe you'll find your answers there faster. I hope you like my videos, subscribe, share them with anybody and everybody, and I'll see you in my next video.